Welcome everyone. So in this lecture I will discuss counting techniques. Well, counting techniques is an important topic of probability and statistics. However, in this lecture I will not cover all the counting techniques. This part will just focus on the multiplication rule, and in addition to that I will also do some examples which will help you to understand the multiplication rule in depth. So let's begin. Well, there are many experiments in which all the outcomes of the sample space are equally likely to occur. And one such classic example is of tossing a coin. When you are asked to find out the probability of getting a head, then the first thing you need to find out is that what are the total number of outcomes in the sample space. Well, there are two outcomes, head and tail. So as shown in this slide as well, the total outcomes which are equally likely to occur is basically represented by capital N. And the second thing in which you are interested is small n. Small n is basically the outcomes that are contained within the event A. In our case of tossing a coin, the event of interest is head, and we know that there is only one head, so small n is obviously 1, and because you were asked to find out the probability of getting a head, then the probability of getting head will be equal to 1 by 2. Well, the purpose of showing this slide is that even previously when you were doing all this computing probabilities of different events which were equally likely to occur, in that cases also you were basically computing the total number of outcomes. So total number of outcomes is a very important factor, and we need to find out that. In this example we are given with a fair dice, and we are asked to find out the probability of getting 3. So first of all, to compute the answer, I need to form a sample space, as this can be seen over here, and the total number of outcomes in this case will be 6, because a dice has 6 sides. Each side has a certain number of dots, so I will get total 6 outcomes over here. And because I have to find out the probability of getting 3, so I have created an event A, and event A is highlighted over here, in which basically 3 is residing. So to compute the probability, first of all I need to check whether this case is of equally likely outcomes or not. Well, because we were given with a fair dice and all the outcomes are equally likely to occur, so the probability of getting 3 can be computed using the formula that was shown earlier. But before that I need to find out the total number of outcomes, because in this case the total outcomes are 6. So this is very simple. Capital N is equal to 6, and all these outcomes are basically equally likely to occur. Secondly, I need to find out that how many outcomes are present in my event A. In this case the number of outcome is just 1, so we are having small n is equal to 1. I'm using the formula given on the previous slide. I have computed the probability of event A, and which will be equal to 1 by 6. So in this way we can see that how important is finding out the total number of outcomes in an experiment. Next is the multiplication rule. Before stating that rule, I will start with an example first. Let's suppose that 3 students are given a task to format a report, and some options are given to them that for typeface they can use either Cambria or Arial Black. For font color, they have a choice of 3 colors: purple, blue and green. And for font style, there are 4 different options: bold, italics, underlined and regular. Well, there are different variations that these 3 students can make use of, and that is shown in the next slide as well. As you can see over here, let's say student 1, he or she makes use of Cambria as a typeface. Then for font color, she will use purple and keep the font bold. Another student also makes use of Cambria, but the student selects font color blue and keep the text regular. And the third student makes use of green color and keep the font regular. So in this way, there are so many variations that it is very difficult to make a map of all such variations. You can try over here. There will be so many variations that it will form a complex network, and it will be difficult to get the total number of such variations. So we are basically interested to find out all such variations and the total number of actually such variations. Here in this slide, those variations are shown. Some of those variations are basically shown that a student can make use of, like Cambria purple bold, Cambria purple italic, Cambria blue bold. Likewise, there are many such variations, and this is a very small list of such variations. Okay, now because we are heading towards the multiplication rule, I will here define some variables so that we can then substitute the values in those and make use of the formula that will help us to calculate the total outcomes. Here we have defined k components. Well, in our case, basically we had 3 components. Number 1 was typeface, second was text color, and the third was font style. So total such components in our example is basically 3. K is equal to 3. And for each component, if I check that how many outcomes are there, let's say k is equal to 1, which basically shows typeface. It has 2 outcomes, that is are Cambria and Arial black. So n1 is equal to 2. Second component, which is basically text color, it has 3 outcomes: blue, purple, green. So the n2 is equal to 3 in this case. And for the last component, that is font style, we have 4 different options. So in this case, the outcomes are 4 and 3 is equal to 4. So here comes the multiplication rule. If an experiment comprises of k components, where each component consists of nm outcomes, where m is equal to 1, 2 till k, then the total number of experimental outcomes is equal to the product of all the outcomes. Product of all these outcomes, n1 into n2 into n3 till nk. So, coming back to our example, in our example we have k is equal to 3 because we were having 3 components: typeface, type color, font style. So because of that, we have k is equal to 3, and for each k we have a certain number of outcomes. So we will basically take the product of all of them. We have 2, 3 and 4. Just take a product of all of them and you will get 24 possible outcomes for this particular case. So that is why I was saying earlier that it will be difficult for you to find out all those variations and show all those variations on the figure. So in this way you can see that how this becomes easier using the multiplication rule. Well, over here what I have done earlier, as you remember that we had 3 different color options, but here what I have done, I have limited the number of colors and now I have just restricted it to color green. So now the student has options for typeface, and they have options for font style, but for color they have to make use of green. So in this case, if you are asked to find out the different number of variations that exist, again we will just take a product of all the outcomes. For typeface we still have 2 options, so 2 outcomes, we will still have 2, and for k is equal to 2, that is text color, we have just 1 outcome, so n2 is equal to 1. And for the font style we have 4 outcomes, that is we have basically 4 different options, so n3 is equal to 4. Take the product of all of them and we will get 8. So 8 possible outcomes exist in this case. So you can see that earlier there were 24 different variations available, but this time we have 8 different variations available, and the number got reduced because we have limited the color use. We have restricted it to green color. Okay, in this case now I have even restricted the options for typeface. Earlier, as you remember, that we had Cambria as well over here, but now the students have the choice of, in fact they are restricted to use Arial black for typeface. Color is green, they have to make use of just green color. So n1 will be equal to 1 and n2 is equal to 1. And for font style we still have 4 outcomes, that is 4 different options. So in this case the variations that exist will be 1 cross 1 cross 4, and that is 4. So now the variations have further reduced from 8 to 4, and here now we can even write those variations, because earlier it was not easy to mention all the variations, 24 variations, but here I can write the students have variations that they can make use of Arial black, green, and keep the font style bold or italic or underlined or regular. And if you have to find out the probability, that what is the probability that a student makes use of Arial black, green and regular, then in this case, if you expect that all the 4 possible outcomes are equally likely, then the formula that we earlier discussed, small n divided by capital N, we can make use of that formula, 1 divided by 4. So in this last case, what I have done, I have for component typeface, I have just given the students one choice, that is in fact no choices, just given that they have to make use of Arial black. For color they can make use of green, and for font style they have to use regular font style. So as you can see, there are no choices left for the student, and all the 3 students they have to make use of these 3 options. In this case, if you have to find out the variations, and there is no need to even make use of the formula, that because you know that only this single option is available for you, that you have to make use of Arial black, green color, and text font style regular. Even if I substitute these outcome values into this formula of n1 cross n2 cross n3, I will get one possible outcome. So You can see that how you can make use of multiplication rule and find out the number of possible outcomes in case of complex examples. So I hope everything is clear regarding multiplication rule. We have just tried to cover the basics of the multiplication rule, and if you have any queries, you can post it over here. Thank you.